Good morning. Friday, April 23rd, and we're going to talk about days 1, 2, and 3 here. Okay, so let me zoom in here if I can. There we go. All right, so today's lesson is going to be just sort of trying to tie in days 1, 2, and 3. All the concepts and material brought up in those lessons are going to hopefully get tied in here, and hopefully when you leave, when you're done with this lesson here, hopefully you have a better idea of how trig works, okay? And so you'll notice something about all of these triangles here, all right? All the sides of these triangles, okay? They're all proportional to each other, all right? That is going to play a big part into the answers that come out of 1, 2, 3, 4, and 5, okay? You're going to hopefully see some sort of pattern with all the answers coming out of these similar triangles, right? And they're similar because all these sides are proportional to each other, all right? And so anyway, hopefully you'll start to recognize the pattern here. Okay, so let me choose a different color here. I'm going to we'll go dark green. Actually, we already got a green on there. How about dark purple? Uh-oh. Well, okay, phew. I thought I was going to have a sneeze right in the middle of the video. How about it? All right. So, question 1 says, what is the ratio for the sine of A? Okay, so we're talking about this angle over here. So the sine of A, remember sine is equal to some old hippie. And so in this case, the sine of A is equal to opposite over our hypotenuse, which is 16 over 20. Put that in a decimal. Pretty sure it's 0.8. Let me check to be sure. I don't want to be telling lies. Yep, 0.8. Okay? So there's the ratio for that one. All right. Let's go over to the cosine of C. Okay, so remember cosine. Actually, I don't need that parenthesis there. Looks a little sloppy. The cosine of C is equal to the adjacent over the hypotenuse, or caught another hippie, right? So, in this case, the cosine of C is equal to the adjacent over the hypotenuse, which is 32 over 40, which is equal to, again, 0.8, if I'm not mistaken. Yes. Otherwise, what will be the point of this lesson, okay? So if you notice, all right, the sine of A is equal to the of C. Right? Just something to notice there. Okay? All right. Now, let's go down to actually finding these angles. Okay? So in your calculator, make sure you're in degree mode. Okay? So you go to mode, go down, select, well, initially with your calculator in its default setting would have radian selected, so you want to make sure you have degree selected, hit enter, and then exit out. Okay, so it says the sine of 53.13 degrees. Okay, and what do we get? 0.7999. How many nines? 4 nines. 89281. Okay, very close to 0.8. Okay, so something's going on with this angle measure here. All right, now I'm asking for what is the ratio for the sine of A. Now, all these triangles are similar, which means their sides are proportional. So it should be no surprise that, okay, when I do the sine of A, this is our opposite, this is our hypotenuse. Okay, so the sine of A is equal to 24 over 30, and again, is equal to 0.8. And then I'm asking you to do the inverse sine of your ratio for A. So the inverse sine of 0.8 is equal to, well, how about it? 53.13. Okay? And so the reason why I'm asking you to do that is because what your calculator does, right, is it takes that ratio, right, created by this degree angle, or this, this angle measure, right? So when you have 53-degree angle measure here in angle A, the ratio created by this opposite and our hypotenuse, right, as long as these are similar triangles, right, as long as these guys have those two pieces, okay, 90 degree and a 53.13 degree angle, okay, the ratio created by that opposite side and that hypotenuse side in reference to angle A is always going to be 0.8. And if you look up here, right, and I typed in what is the sine of 53.13, what is the ratio it gave us? Very close to 0.8, right? If we were to round that up to the 10th spot, definitely be 0.8. So what I'm trying to sell you on is this, okay? The ratio created, no matter what the size of the triangle, if you have a 53.13 degree angle here as an acute angle, okay, the ratio created by the opposite over hypotenuse side is always going to be 0.8. And then what your calculator does is it has all that stuff saved in the table, and so what you can do, right, and so in this part here, right, we found the ratio, and then you can take that ratio created by that opposite and hypotenuse side, take the inverse of it, and it actually gives you the angle measure, okay? All right, so if you put this guy in your calculator, right, and did the inverse sine, you would get, well, 53.13, okay? So let's go over to number 4. All right, it says, what is the cosine of 36.87? So cosine of 36.87. What am I getting? Oh, lo and behold, 0.79999898281. Okay, so again, what it's saying is the ratio created by this adjacent side and this hypotenuse side for any right triangle that has this angle measure and, of course, a 90 degree, it have to have a 90 degree angle, right? Otherwise it wouldn't be a right triangle. But the ratio created by that adjacent and hypotenuse side will always be 0.799989281. And if you were to round that up, right, very close to 0.8. Okay? So let's take a look at the cosine, the ratio created by these two sides, 20 over 25. So the cosine of C is equal to 20 over 25, which again, type that in your calculator, 0.8. All right? And take the inverse cosine of 0.8. What angle do you expect to get? Hopefully, so I recognize the pattern here. This is going to take you right back to 36.87 degrees. Okay? Which is what we have there. Okay? So we took the ratio created by those two sides, and we actually can find the angle measure. Okay? So lastly down here, this is where they're giving you an angle measure and one of the sides, and you got to use these trig ratios to come up with the other ones. Okay? So we want to find AB. Right? So in reference to angle A, right, this is always going to be our opposite side. This will be our adjacent, and this side will always be our hypotenuse. Right? So to find AB, we're going to need the trig ratio that involves my adjacent and hypotenuse side. So this one's going to be the cosine of 53.13 is equal to our adjacent, which is going to be x, all over 2.5. Okay? And how do we solve this? What you have to do is you have to multiply both sides by 2.5, because remember, this is actually a number here. That's some number. That's some ratio created when you have a 53.13 degree angle. Okay? So by multiplying both sides by 2.5, we're left with x on the right and 2.5 times the cosine 53.13. It's equal to 1.500, and we're just going to round it to the nearest tenth spot. whoops. So we're going to say, whoops, 1.5. Okay. And our last guy here, we're trying to find BC, and so that's going to be our opposite and our hypotenuse, right? We need those two ratios, so this one's going to be the sine of 53.13 is equal to opposite over our hypotenuse. So again, same pattern, multiply both sides by 2.5, cancel, cancel, left with y is equal to, and we're going to round it to our nearest tenth spot. And what do we get? Well, when you round it up to the nearest tenth spot, it actually takes us up to 2. So, let's take a look at what our triangle sides are. Shouldn't be a huge shocker here. Okay, this one is 1.5 down here. And this one is 2, which again, proportional to all of these guys. And matter of fact, all of these triangles are proportional to our two triangles down below. Okay, our most simplest Pythagorean triple, which is the 3, 4, 5, right? So 3, 4, 5, we got 6, 8, 10, 1.5, 2, 2.5, 18, 24, 30, 15, 20, 25. Okay, hopefully you're starting to see that pattern. Okay, so it says, what is the ratio for the sine of B? Okay, so sine of B is equal to some old hippies, so 8 over 10, which is 0.8. Okay, cosine of C is going to be, again, 8 over 10, or 0.8. And what's the ratio for the tan of B? Just for fun, that one's going to be our opposite over adjacent, which I'm talking about this angle here, so opposite, adjacent, 8 over 6, or 1.333 repeating. Okay? And so then I want you to take the inverse cosine of 0.8. Okay, so again, looks like I'm getting 36.87. Inverse sine of 0.8. Shouldn't be any shocker. 53.13. The tan of B. Okay, so we found that to be 8 over 6. Take the inverse. And what do we get? Oh, 53.13. Right, and down here, the tan of C. Okay, so switch it up a little bit. Adjacent hypotenuse. So if you notice that they just switch. Okay, so now this one's 6 over 8. And you take the inverse tan of 6 divided by 8. What do you think you're going to get? Oh boy, 36.87, which is the measure of that angle. Okay? So we do the same thing down for this guy right here. So the sine of A is just going to be 4 over 5. Come on, pen. Don't quit on me now. 4 over 5, okay, which is 0.8. Okay, cosine of B, which is adjacent over hypotenuse, adjacent hype, okay, 4 over 5. Again, 0.8. The tan of B, okay, so adjacent hypotenuse, all right, so 3 over 4, which is 0.75. Then we go down here and we take the inverse of those ratios again. And hopefully we know what to expect here, right? So this one's going to be 36.87. 0.87. This one over here is going to be 53.13. All right, the tan of B, well, we already found that, is 0.75. Okay, so you take the inverse of that. What do you expect to get? Oh boy, 36.87. And finally, the tan of A. Okay, so opposite over hypotenuse. Okay, take the inverse of that guy. What do you expect to get for A? Hopefully you've figured out the pattern here. 53.13 degrees. Okay? So, anyway. Hopefully that sort of ties these things in here. All right. The inverse trig function, what it does is it actually takes that ratio and gives you the actual angle measure here. All right. So what we found in all of those is that, well, we ended up having the same angle measure for C and same angle measure for B. And the reason why that works is because these are similar triangles. These sides are proportional to each other. Right. And also, okay, these proportions come from the fact that these angle measures are the same in all of these triangles. Okay? So anyway, hopefully that sort of ties this in. Okay? The rest of the homework is for you guys here. All right, well, actually, crap. I'm going to have to cut this into 2 parts. But there's part 1. All right? I'll do 3 and 4 in the next video. Okay? So there you go. Good luck with the beginning.